The fluorescence monochromator unit is used to measure excitation and emission by fixing either the emission or excitation wavelengths respectively. While fluorescence and CD data can be acquired simultaneously using various spectrum manager measurement programs, this video will discuss how to obtain excitation and/or fluorescence spectra using the excitation emission spectrum measurement program. Before setting up the excitation or emission scan measurement parameters, we will first need to adjust the detector voltage. Make sure the shutter is open and place your sample into the sample compartment, and in the measurement program, go to Control, Detector. Detector 1 tab corresponds to the PMT, while the Detector 2 tab is for the fluorescence monochromator detector. Click on the Detector 2 tab and make sure Manual is selected in the HT Volt Mode drop-down menu. We will now set the HT voltage to a constant value so that the fluorescence signal can be monitored by the DC voltage. To do this, enter an appropriate voltage in the HT voltage text box so that the maximum fluorescence intensity, read by the DC voltage, is about 1 volt and click Apply. A good starting value is about 650 volts. Take care not to enter a value so that the DC voltage is larger than 2 volts. Once the detector voltage is optimized, the measurement parameters can be set up. To do this, select the parameter icon in the menu bar or click Measure Parameters. In the parameter menu box, the first tab selected will be General. If emission is selected in the Measurement Mode drop-down menu, specify an excitation wavelength in the emission wavelength range you wish to measure. If you don't know the wavelength your sample excites at, measure the sample's absorption or excitation spectrum and use the wavelength of the absorption maxima. The data pitch determines how frequently the monochromator acquires data points. Since fluorescence peaks are typically broad, a 1 nanometer data pitch is a good starting point. The DIT is the digital integration time or the response time. The DIT specifies the amount of time the detector collects photons before transferring the charge to the A&D converter for signal processing. The longer the integration time, the better the signal to noise. A good starting point for selecting the DIT is 1 second. While the bandwidth on the emission monochromator is fixed at 10 nanometers, the excitation bandwidth can be changed. The bandwidth determines how much light reaches the sample. The smaller the bandwidth, the less light throughput and the lower the signal to noise, but you can achieve better peak resolution. To measure the excitation spectrum, select Excitation in the Measurement Mode drop-down menu. Since the excitation spectrum is measured using the CD's monochromator, the scan mode and speed must be specified. The continuous scan acquires a signal at each wavelength while moving across the desired wavelength range. Step scan stops the monochromator at each wavelength to obtain a data point. The scanning speed is the speed at which the data is collected. The Control tab allows you to select whether to open and close the shutter automatically. The Information tab allows you to populate the desired fields, such as sample name, concentration, and solvent. These comments can also be displayed in the Comments dialog box before the sample measurement. All information provided here can later be viewed in the Information tab and Spectra Analysis for each spectrum. In the Data tab, you can select whether to automatically save your data, as well as to specify which folder to save it to in the format the file is saved as. Saved data can be sent directly to Spectra Analysis once the measurement is finished. You can also choose to save your measurement parameters as well as open previously saved parameter files. Select OK to save these parameters. To begin the measurement, select the sample measurement icon or go to Measure Sample Measurement.